Okay, then let's start. Hello, welcome to this last class here in this room. It's a masterclass together with Norman Goldberg and David Caro from tesa. So the topic today is driving innovation, advanced adhesive technologies for automotive excellence. Yeah, and before we start this masterclass, I would like to introduce you to tesa, the company, and also to our two main speakers here. And in between, while I will be talking, there will be some items built up here. So be surprised what we will show you afterwards. Okay, so like Tempo, you all know Tempo. tesa is also a brand nearly everybody knows, especially here in Germany. And it's a brand name for adhesive tape. And tesa is one of the best known brand names in Germany, I think. Yeah, and the SE, tesa SE, stands for Societas Europaea, and tesa SE is a subsidiary of Beiersdorf AG. Yeah, it belongs to the chemical industry, and its main products are adhesive tapes and other adhesive materials for consumers and for the industry. So, and there are many, many adhesive tapes everywhere in industrial products and also in our everyday products. And maybe, as you know, they stick very, very well and firmly. And if you buy something new, you have to pull off the price labels that often they don't come off very easily. And now that's how we come to our topic today. The future of gluing lies in the ungluing. And this is a very important new category. And the company tesa is working on this. And yesterday, maybe some of you have been there, yesterday evening, they received the MMK Award of Excellence in Sustainable Engineering, because now it's all about promoting sustainable innovations. So, and in today's masterclass, the focus is on the industry of automotive. The title is Driving Innovation, as I said already, Advanced Adhesive Technologies for Automotive Excellence. And now I would like to introduce the team, the CEO of tesa, Mr. Norman Goldberg, and David Caro, the Corporate Vice President and the Head of Business Unit Automotive at tesa. Afterwards, you will get a new presentation, a live experiment, and it's a lot of time for questions as well. So first, let's start with Norman Goldberg. Dr. Norman Goldberg now is the CEO of tesa since the year 2020, and with his international experience, he assumes operational responsibility in the direct chemical and consumer goods industry. He holds a doctorate in chemistry and initially researched and taught at the universities of Cornell in USA and at the TU Braunschweig. He started his industrial career in 2000 at Henkel in Düsseldorf, where he held various management positions in sales and in the marketing, as well as global research and development. Until 2016, he was managing director and member of the executive board of Lohmann GmbH. And since 2017, he has been a member of the executive board of tesa SE. So we switch to David Caro. Welcome. He's the corporate vice president and since 2021, the head of business unit Automotive at tesa in Hamburg. Previously he worked with Henkel for 19 years in various positions in the automotive sector, most recently as corporate director, global head of engineering, automotive OEM. And he started his education as a mechanical engineer, as well as business administration and in the management. And he started his education in Barcelona, Spain. And he worked with SEAT, and the other company was?
SEAT.
SEAT, okay.
No, I was not working with SEAT. I was working with Henkel.
With Henkel, but you had your experience at sales as well.
Yeah, of course, yeah.
Okay.
And Ford and PSA, Stellantis,
okay, so
Opel,
the different,
everyone.
Okay, so thank you very much. Yeah. Now I think we start the presentation. First, Mr. Goldberg,
Super.
and then we go on.
Thank you for the kind introduction, and good to be here. By the way, this is a master class. I've never given a master class, but I like to interact with students. Students are curious, so feel free to ask questions, jump in between. If there's something that comes up your mind, yeah, we should have a dialogue. I think that's the way we learn much better. So really, I enjoy, and I think David as well enjoys getting questions, and we'll try to give you answers. If not, we end up in a discussion. Yeah. So what we want to do today is give you a bit of a background what tesa is, but really we want to talk about tesa and the automotive industry. That's why I asked David. He's the head of automotive. He knows, yeah, basically everything that happens in the automotive world much better than I do. I'm sort of above this thing a little bit. So I asked David, please help me out, because I'm sure you guys are really smart engineers and you will ask difficult questions. So then I can always say, David, please answer those questions, right?
No pressure.
You know, no pressure, right? So, as you know, we are actually in Germany. You know us as a household product, tesa film, of course. But at the end of the day, we're an engineering company. We're an engineering and a material science company, because 90% of our products actually end up in technical, in industrial products. 90% of our business, at least from a value perspective, ends up in automotive, in electronics, in the printing industry. This wonderful product that all of you know quite well. You've had already 30 to 50 of our products in your hand because they're in here and you don't know them. You wouldn't know that, but that's what we want to talk about today. We're in the appliance industry, in renewable energies, in the building industry. You find us everywhere, basically. Here's the sales numbers, and basically that shows you that we're almost a 2 billion euro company. That was my target set for, basically now. Then Corona came, and we have, since that, and companies have been a little bit flat over the last 2 or 3 years, but overall the company has grown tremendously over the last few years. You see already also from a market split, from a regional split, 1/3 of our business we do in Asia. That's quite remarkable, I think, for an international company. And Asia, Southeast Asia, China, but also Japan is an important market for us, and we're doing quite a lot of business there. I just mentioned to you 90% of our market is industrial. Here you see 22%, so only 80% being industrial. What I said before, from a value perspective, we do much more, we generate much more value in the industrial business. That's turnover. But actually, consumer business is, you can't earn much money in consumer business. You earn better money with engineered products, and that's what we want to talk to you about. We are a multinational company. You see here roughly 7,000 adhesive solutions that we produce on our machines worldwide. We are basically existing on every continent. We have production in Asia. You see here in China, actually. I was just there last week. We have a big production site. We also have production in Vietnam now. We just opened a production and built a site in Vietnam. And then we are present in the US. We are present in Europe. In Germany, we have 2 production sites, Hamburg, Offenburg. And then in Italy, we're in Concagno, in the north of Italy. So, really engineering competence everywhere. And we have our headquarters in Hamburg because, yes, we are not a subsidiary. I wouldn't call it like that. We are sort of the Gallia. Do you know the Gallia and the Romans? Do you know that analogy? Okay. We are the Galicians, the Gallia. There's Rome. They do creams and they sell dreams. And we do actually, in Galicia, we make actually real products, and we do engineering stuff and do fun stuff. We are a company, I think, with a lot of nerds, right, at the end of the day. Yeah, we like to glue things together. We like to talk automotive engineering. We like to talk with the Apple engineers in Cupertino and discuss with them what's happening on material science. And then we need to produce those things, and that's actually quite complex. The machines that we run, our engineering competence is really, I think, quite impressive. And that's really where our competence lies. Of course, we are also swamped with this regulatory stuff. I don't want to bore you with that, but this is, for me as a CEO, at the moment, quite a tricky situation because we have to balance that. You can imagine a lot of competition works maybe in Asia or works in the US, and they have a different level, a different playing field. And we have to actually work with these regulations at the same time, also have to run a global business. So that's quite a challenge. But I can tell you, as a company, I think we are smart. We are quite agile. And we handle that quite reasonable. But sometimes I get gray hair because if I believe on the legal guys, I should be hiring more legal guys than engineers, and I don't like that. I like to hire engineers and chemists. So what else is there about tesa? Actually, we want to dive straight into the automotive market, right, David?
That's right.
You've been in automotive all your life, right? worked all over the world for automotive.
Close to 30 years already. So then I look maybe a little bit younger.
You started when you were 10, I think. Yeah. Oh yeah. You started.
I use a lot of creams from Bayersdorf, I have to say.
But you worked in the US.
I worked in the US. I worked in Detroit, in where you have the big three, Ford. Now it's called Stellantis, and also General Motors. I was working there. I was responsible of US for automotive for a while in my previous company, and then when I've been working in Spain, obviously I'm Spanish. I'm from Barcelona, and in Germany I've been passing a lot of time as well.
So we talk a little bit.
Let's talk about automotive.
In adhesives.
Yeah, let's talk about automotive and adhesives. Yeah. Well, that's a fascinating world, automotive and especially adhesives, and especially the engineering which is behind of it. So then it's a little bit an unknown thing. But before to start on this topic in terms of going more technically, I wanted to have a little bit of a pull here. How many of you have bought a car this year or have intention to buy a car this year?
You ask students, that's maybe...
That's the change of generation. It's important also as well, this question for exactly this.
Yes. Fair enough.
Nobody.
Oh yeah,
one,
three here in the front. 2, 3, 4.
3. How many people are we here? I don't know, who's how many people are we?
40.
40, so then it's around 10%, yeah? 8,
You don't make him happy, he wants more cars to be sold.
You see, that's a little bit the problem in automotive right now. And how many of you have bought Chinese cars? I hope nobody, huh?
Oh, what?
No, we are having a moment of uncertainty, a lot of volatility. You know that already. So and our customers, and especially in Europe, are having a tough time, but they are going to recover. They are going to be much more stronger. And I hope everybody is buying cars, right? So then situation is a little bit tricky. Let's put it like this. However, the cars have been changed, have been transformed. It's not like it was 10 years ago. 10 years ago, it was totally different. But this now is kind of a lot of people are saying a mobile phone with wheels or whatsoever. Now with electrification, with batteries, that's moving on to the next level or the next direction of engineering, and this is giving us the opportunity to bring new solutions to our customers. And this is where we are working really tirelessly from the innovation perspective to bring new solutions. So then I wanted to give you a little bit of a background what we are doing in a car, right? So then before we were doing basically these two parts, sealing and paint technologies, and also sticking the parts together from the exterior part of the car. So that was the business until 6-7 years ago. But now we increase this part to the interior side of the vehicle where we have electronic components, and also big chunk here to the batteries, because batteries are totally new, but we are using mainly the technology that Norman was explaining before, that everyone is using the day-to-day, so the electronics. So then what we have been doing is that leverage our technology to bring it to automotive, yeah? And then we are becoming more kind of part of a little electronic division inside of tesa as well for automotive, yeah? So then where we are doing displays and batteries, yeah? But today we are here to, a part of that, to explain you a little bit more about what is the trend right now. So the trend right now for adhesives, you know what an adhesive should do, yeah? So then if I ask you what an adhesive should do, it should bond, right? Should keep the things together, should hold the wall together. That's our motto. But then what we want to do as well, and then this is the things what are changing right now with the sustainability and right to repair. You probably have seen during the last couple of days all the presentations and so on. So then we need to give more cycle time to our products, and we need to recycle, and we need to be able to repair them. So then the adhesive now needs to be debounded, needs to be removed. And when does it need to happen this? If you drive a car and suddenly your display falls down, this is not a good thing, huh? So then you need to do it when it's demanded, when you really want to do that. And for that, we have our engineers and chemists and so on are starting to work on that. So as you will see here, one technology that is coming from the mobile phones, and the mobile phones before the battery was clipped inside. Now is bonded. And this, every time we want to repair this battery, we debond this battery with a stretch release, let's say, adhesive. How do we achieve that? We achieve that with a high elasticity adhesive, where we lose the peel on the surface, and then obviously then after that, boop, you can remove it. And you are going to see it in a few minutes. But let me show you a little bit the properties, because it's an engineering place here, right? So then everybody wants to talk about engineering, right? So what is very specific for these adhesives in automotive? It has to hold the cycle of the car, has to go from minus 40 degrees Celsius to plus 80 degrees Celsius. It has to hold there for the minimum 12, 15 years, aging resistant, and has to have a strength. But then from the other side, what our customers that they want to have is that it's simple, that we can remove it easy, that we do not have residues in the surface, and then also that there is no damage. So I'm going to show you how is it working, how a display is made. So this is a very schematic way, but then here you will see how our technology works. So then there is initially some electronic components that is bonded and then immediately removed, you see? And then we can also open the whole display. You know how much a display costs? A display like this BMW, let's say 3 Series, 5 Series, whatsoever. You know what the cost is? That's a little bit less. No, 5,000 euro will be. No, it's 880 euro approximately.
Okay.
So, approximately. But 880 euro, you multiply it by 350,000 cars they produce every year. It's a lot of money, huh? So, and then if you consider the yield they have, because sometimes they have an electronic component that does not work well, and then they have to rework it and so on. This is tons of money for our customers. So then this solution also allows our customers to remove, if there is a problem, mount it again, done. Otherwise they have to spend 800 euros more in a car. It's a lot of profit they lose.
So you're saying that happens during the assembly process, right?
During the assembly process
because
happens.
There's a lot of mistakes that happen in the assembly of the cars.
Yeah,
yeah?
That's right. Good. Oh. But also we have some other stuff in the battery. So in the batteries, can we use this thing? Can we use the same process, right? And then our engineers thought about it. So then, what can we do in a battery if we have to repair cells, right? And then we thought about this technology. However, there are several applications in the battery that we have in the cells, right? So then, we have inside of the cell, we have adhesives, we have outside of the cell to prevent electrical discharge between cells. We mount the cells. We have insulation obviously in the battery box. Also we have put adhesives there. And then when we mount everything together, or we seal the total battery, this is where we identified that this solution could work. And I'm going to show you now one application for this. I don't think it has music. No, it doesn't. So that's a prototype, nevertheless. But you will be able to see, So then first of all, we remove the thing.
What is it? What kind of?
It's a this is the lid. This is on the top, the sealing part of the when you have to open the battery, and you remove it very simple, So with stretching the adhesive, the same concept, but also we can use the same concept to remove the cells. We remove you see how is it working? And then after that, with that, clack, you can detach the battery. Then it gets hold, and you can easily remove.
And David, this is something you cannot do with a conventional adhesive.
Absolutely not, no.
Yeah, because that will always stick. You can't get it out. It'll
Exactly.
need a different material. So
you need a different material.
Tape. Yeah.
Exactly. And that's why we need the tape that has these properties. Yeah. So that's good. We launched these products 1.5 years ago. We have already customers that we won projects with them. Okay, so before to go to the next one, I want to give you a challenge. I have to give you a challenge that if you want to see this material, do you want to see this material? Do you want to see how it works? Yeah, here we go. Okay, who are the most strong people here? Not me, eh?
Yeah.
Who are the strongest? You are the strongest. Who else? Who wants to bet this guy?
Yeah.
You. I saw another guy there. Come on. We prepared for you something that you will be able to test this adhesive. Here you have this adhesive. You see it here. And we have 2 polycarbonate here, so no worries. You can pull if this breaks, which I promise is not gonna break. So then is a cable, so then you are not going to fall down. Yeah. So then no problem. Safety first. But I would love that you try to see about who is the strongest, and if you can basically
Detach it.
Detach it. Yep.
I just want to take a look.
Just pull it.
And I think you had this, Oliver Blume did that, right? The CEO from Volkswagen a few months ago.
That's right.
He didn't succeed in pulling it apart.
Nope. No.
Let's see here. Okay.
Come on.
Oh,
you
that's
made it.
Effect.
Okay.
That's good.
You guys are stronger than the CEO of Volkswagen. That's not bad. Yeah.
Well, the CEO of Volkswagen was not able to make this.
Yes. Yeah.
And we were showing it to him a few days ago. So then I'm going to show you what is the mechanism, yeah? So then the mechanism is this one with the 2 polycarbonate, and then after that, very simple, you pull it, and and then it's done, right? So I'm going to give it to you, some of them that you guys can try. So I give some of you here, you pass it by, and then I give some of them over there. I don't know if we have for everybody. Yeah, you got it. You have this here.
They did that already.
You pass it by. So then you see how simple it is. You have to pull it exactly the same direction of the adhesive. Don't pull it at 90 degrees because otherwise the adhesive will break. But if you pull it directly in the same direction, you will see. Yeah. So
and
then
it looks a little bit simple, this material, yeah. But at the end of the day, it has to be elastic and adhesive at the same time. So not so trivial to make. And now you can imagine they're different. Yeah, we have different surfaces, so we adjust those materials. Yeah. But this is just one technology.
That's one technology. That's the cool thing. The next challenge. You wanted to tell me, okay, but this is maybe not strong enough, yeah? Maybe it's not strong enough because the batteries are changing. And put it maybe here. I'm a lefty, that's why I go in that direction. So the batteries are changing. So do you know what's going on in the batteries right now? So then we are going to from the cells stuck in a module to the cells stuck in the battery case. So what does it mean that the batteries are going to win much more space? They are going to gain capacity on range, and they are going to reduce weight. Yeah, but for that you don't have a mechanical system that holds the cells together. So then, what do we need now? We need a structural adhesives to manage this. Yeah, and then the cells are going to be stuck together. So then what do we have as the next challenge? And we accepted the challenge. So then we have shear strength above 6 megapascals. Yeah. Sometimes the thing is that you cannot access to pull inside of the battery. So you need to do another trigger mechanism. Not only a mechanical, but a different trigger mechanism. So then that's why the new technologies are required. Yeah. And let me explain you a little bit the concept. This is a high-level concept, yeah? So then if you think about this is a battery cut by the middle, yes, a section of the battery, and then you have a top lid Then you have an adhesive and a structural tape who holds the batteries on the top. And then after that, you have the cells here. You have another structural tape. You have the insulation, the thermal conductive material to transmit the heat of the battery, because when you charge the battery and so on, it creates heat, and then you need to eliminate this heat, and then you have a cooling plate, right? So then at the end, what we wanted to do is that we want to be able to either repair these cells, or when it arrives to the final end of the car, so then we want to remove them and recycle them. So what happens right now with Tesla? You know what happens with Tesla? The battery of Tesla is integrated inside of the vehicle, and is with a very strong adhesive inside, and then they have to destroy it. They cannot do that. So then, and this is triggered also by the European new way of doing things. Yeah. So then the European technology is requiring this. Not the American. The American, they put it there, boom, you know, and it works very well. But then after that, how do you recycle this? Yeah. So, but here we have a different perspective in terms of sustainability. So that's why we are a little bit more advanced in that regard. So we have a trigger. How do we do that? I will explain you later. The thickness of this material is very thin. It's 100 microns, so it's 0.1 millimeter. Yeah, so that you think that the technology here behind is high level. And then after that, you apply wherever you want this trigger, and then the battery gets free. Yeah. So let's go another video, and you are going to see how it works. Here, in that case, the trigger is electric. So we apply a differential potential of 12 volts, and with a little bit of not too much intensity, is very, very little. And then after that, after a few seconds, you will see, clack, done. So the adhesive is working from the molecular perspective. The ions are moving inside. And then after that, then lose the resistance, the share. Huh? That's a good one. Then I'm going to show you here another trigger mechanism. The trigger mechanism here is that we do it by heat. We put heat during 5 seconds with induction, and then, as probably you have seen it, the battery pluck falls down. So then at the end, we remove basically the resistance of the adhesive, and the cell, which is very important, cannot be heated up more than 60 degrees. So then it's arriving to 60 degrees, I think, a couple of seconds, boom, done. Good, but that's not all. Yeah, that's not all. So then, at tesa, one of the values that we really think about is that we do not only produce a tape or a solution for a tape to stack. We also engage with our customers to apply this tape. So we have an engineering team who is directly developing solutions that we can apply this tape automatically. And then this is really our unique cells of USP that we call USP. Unique sales strategic. Yeah. So then, in order that basically when we have the tape and everything is specified, we are able to automatically engineer the solutions. Yeah. So then, what do we do with that? For example, that's the Porsche. That's the Porsche line, but it's just a video. But we are working with Porsche, with the Volkswagen Group on this, and then we apply directly the adhesive in the body in white of the car, so to seal the cavities. So then all of this is designed by tesa with our patent. We have patents on that, and as you can see, the robot is directly applying it.
That's for holes, right?
That's for hole covering. So then we seal the cavities. So then in a car you have a lot of holes that in order that the paint is going through and whatsoever. And then in that case, this hole needs to be closed, either with a plastic plug. That some years ago you had the people applying plugs the whole day. So now we are doing it automatically, and we do it with tesa. And another one. So you may think about the batteries. Yeah. So then in the batteries, we seal them automatically as well. You see the old adhesive is going through. The adhesive is this part.
The tape, huh?
The adhesive tape, yeah. And then we develop all this application in order that this could be applied. Yeah. In a standard adhesive, this is quite simple. Yeah, it's just a doser and it's the robot and then a nozzle there and then that's all. In that case, it's much more complicated. So and then we are really a unique company doing that in the world. So and then that's why we are basically pretty well perceived by our customers. Yeah. What else? So then, with who do we work? We work with more than 30 OEMs. OEMs, you know, we have a bunch of them in the world. So we are present around the world, as Norman mentioned before. And then we work with the big ones, and also, but most importantly as well, with more than 800 suppliers that are delivering to our final OEMs.
OEMs, you all aware of the terminology? Yeah.
Yeah.
Those are basically BMW is an OEM, Volkswagen is an OEM, original equipment manufacturer. It's an acronym in the industry, and original equipment supplier, the tier 1s, tier 2s in automotive. Yeah.
Good. And that's basically it. And I would love to have some questions and some dialogue with you guys. So are we good on time? 8 minutes to go.
We have 8 minutes left, but I think we are the last session, so maybe
Thank you.
we have like open space. Yeah. So yeah, please feel free and ask, because now is the chance.
Hi, my name is Jessica. I'm an innovation manager for sustainability at BMW. So part of my job is finding sustainable options for our product. And one area we are looking at are adhesives. And we are actually trying to avoid adhesives because we think that it's more sustainable clipping or than using adhesives. I still think this is an amazing solution, and congratulations for that, but it's still waste we have here. So do you have maybe some options for bio-based adhesives or, I don't know, other alternatives?
We have bio-based adhesives, we have recycled adhesives. This company now, of course, that I have in my pocket here, we have post-consumer recycled materials as backings. We have bio-based raw materials for our adhesives that we manufacture ourselves. There's so many different products in the value chain. We don't talk about them, and we didn't mention them here. But that's why every application we co-develop. Yeah, and from that perspective, there's plenty in the sort of, how do I call it, in colors we can play with, so to speak, in our toolbox. Yeah. So that's why our engineers are in the project teams of BMW or of Volkswagen when new solutions are being developed, and the requirements are then discussed. You and your team tell us what you need. What do you need in terms of carbon footprint? What do you need in terms of CO2 or other topics? And then we start the developments. That's how it works. Yeah.
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 Yeah, the black tape that you have shown, the material, is it fully homogeneous and anisotropic? As an engineering question.
Well, it's an elastomer.
Okay. But it's coated elastomer. So there are different layers in this product. So
there are different layers.
It's not homogeneous. Yeah. There are homogeneous materials we can also do, but most of the time, because you have different surfaces, you will have sort of an elastomer, and then we will coat it with other polymers. So it's actually relatively. It looks a bit trivial, yeah, but it's quite complex material.
Okay, thanks.
Yeah, and what I think is important for you to realize, what we do is we make these polymers ourselves, I mean, these adhesives, we make the backings ourselves. And then, by the way, you have to produce those materials in high quantities in a completely reliable fashion because, BMW doesn't want to have errors in their products, So basically, or whatever I call it, a mobile phone manufacturer, when they're making 1 million pieces a day or 2 million pieces a day in their production in China or wherever, you have basically zero failure rate, right? So basically, what that means is not only our engineers really, or the chemical guys, the polymer guys need to know what they're doing, but also the production guys and the whole supply chain. This is super, super critical. Yeah, if only 10 out of, 10,000 iPhones are falling apart in the production line, not a good idea. So failure, tolerance, quality management, it's a huge aspect for us in the plants. Digital data as well together. So it looks a little bit, we code something and we produce it, but the whole production, supply chain, back office operation is highly technical and needs to be highly controlled. That's why where there are also a lot of engineers in the production sites. They know how to run those products day by day with high quality and reliability. That's super important.
No, I have to mention, being in the site of adhesives, and I've been in the site of adhesives for more than 25 years now. You see it from one side, what the typical Loctite adhesive is, and then how to produce this Loctite adhesive, or how to produce a sealer, or how to produce structural adhesive in a kind of a bulky way, in a paste way, or doing it how we do it. This is total different worlds. The technology that you require to coat these adhesives, it's tremendous. We do adhesives from a really a tenth of a thickness of one hair until 8 millimeters. Yeah.
That's why we don't. I'm totally happy that you don't like adhesives. We don't sell adhesives. We sell technical tape solutions. Which have and the good news is we can if you want it to be thinner and you want to have a different carbon footprint, happy to do so. Yeah. By the way, clips are also plastic, right? Tricky. Yeah.
And they are noisy. Click, click, click.
Yep.
Yeah. And it's difficult. And it's difficult to dismantle them.
That's David going into sales mode now. You see? Okay. Yeah.
Yes, my question was, thank you very, very much, first of all, for the presentation. And I really like that you made it more interactive with the pulling game, and also by giving out the little
samples.
Yeah. And I also really found it very creative with the adhesives. And I wanted to ask what you would say the innovative process is at tesa, and maybe also some recommendations, because I'm a young student right now at TUM, just entered last year. And what tips would you give to become more innovative as a person?
Oh, that's a good one. Do you want to reply this? I have.
You go about the personal part. I do the innovation part. Shall we do that?
Yeah. Let's do that. Let's do that.
Yeah, I'm curious to hear how you manage people becoming more innovative.
That's a super question. I'm really glad that you are asking this. I cannot give you the truth, and I can only tell you what is my opinion, and you take it or you don't. But what, under my point of view, you really have to be curious. Be curious. Try to understand how the things are working like that, and what can you do to change it, and challenge the status quo. Challenge all the time. Why it has been done like this? Can it be done in a different way? Be curious. And this is going to bring you the innovative spirit. Yeah?
And that's also your process.
Absolutely. But also talking with BMW, in that case, the clips and so on, saying, what can we do for you? And is there any problem? What can we? Is there anything that you are worried about? How can we do the things? And then after that, we bring people together, and then we find the best solution, and we develop it accordingly. And this is how we advance innovation. Yeah.
And then you mentioned you asked about the innovation process. you can imagine there are hundreds of people working in tesa on simply just on development, right? We have, I don't know, 600 chemists, polymer chemists, etc. Then we have a couple of hundred engineers. They come up with a lot of ideas. So our problem actually is not having ideas. Our problem is picking those ideas that actually A, work, and B, also have a meaningful economic result. So we have hundreds of new projects that we could start every day. And actually, to our innovation pipeline, we probably have 500 projects constantly in there. Some bigger, some smaller, some more driven by technology, others driven by customer requirements, and so on. Our challenge is really managing that complexity, making sure that in this innovation pipeline, all these projects move through at a recent time, or we kill fast. We kill projects as well that don't work out. Yeah, so the innovation process is really quite complex to maintain, because if you just let our developers develop projects, they would develop a lot of things, but maybe not in the right time and maybe for the wrong purpose. But what I would also like to tell you, when you go into such an industry, for me at least, it's been a wonderful experience, because I'm also a very curious person, as David knows, by training, as a chemist, by science, but also personally. And we service so many different industries. Yeah, one day I see an aviation manufacturer, the next day I'm at a mobile phone manufacturer. Last week I was in China, traveling to visit all these customers. So many production processes where tapes or adhesives are being used. So for me, such a job is really the most wonderful thing to have, because for a curious person, I've seen hundreds of production lines, hundreds of fabrication places. And that's when you enter such an industry, you can. Yeah, and you can choose, and you can learn a lot constantly.
Can I just ask one follow-up question? Because sometimes, like firms have as their value papers or something, they have we like to be innovative, but we also like to be efficient. And
it's okay, we can hear you.
And I wanted to ask, what's your opinion on innovation versus efficiency? Because the two really don't go hand in hand. And for example, Jeff Bezos talks a lot about like failing a lot to find the one golden nugget. And what's your opinion on that, and how does tesa manage that the trade-off? Yeah.
Yeah, as I told you before, this innovation part, yeah, you have to manage it to a certain extent. I don't believe in the one golden nugget. We have a lot of innovation projects, of course, but we have to manage them also efficiently. And that is a balance, and that's why you need. We have business unit managers, for example, per segments. David has a team of product developers, right? Yeah. They develop products specifically for the automotive industry. We also have an engineer and a technical development organization. They develop new technologies that then later the business units can use. And David and his team constantly have to decide, where do we put our resources? Yeah, do we stop this project or whatever? That's management task. But of course, the better also the result in the business is, the more we can reinvest in innovation. So I think we invest a lot of innovation, but we also have to drive efficiency in the innovation process.
Thank you.
Yeah.
Thank you also. Our time is over, but we have two more questions, and I think it's
happy to take them. Come on.
We should take them.
Yeah.
The last session,
Super.
we have time, and also if there are more questions, I think if you don't mind, we can talk on a bit more.
Or after whatever, easy. Yes.
Okay, so thank you for the presentation and also the interactive part. What I wanted to ask, because you mentioned this in your speech yesterday, if you have any real-life examples from the automotive industry, what the efficiencies are when using tape instead of many screws, and because big screws add also weight to the car, maybe not in smaller ones, but if you think about trucks, and like if you have a percentage, how much you can choose tape instead of the screws, and how much you can, I don't know, how efficient it can get, because you don't have all these different screws and not this weight, because tape weighs way less. So, yeah, if you have any real life examples, maybe.
Yeah, we do several ones. We have several ones. What I mentioned before about to cover these holes of you have hundreds of holes in a car to let go the paint and so on. Before you had to apply it manually. Still, there are a lot of companies that are applying manually.
Plugs or clicks.
Plugs, yeah. and this plugs needs to go then after that into the oven sometimes because they need to activate the hot melt that they have, and then after that to seal and all this, and then we replace that by a engineered tape, and then we save weight on that case, but also we save manpower, and then we can dedicate this manpower to other tasks. Yeah, so then there's a lot of cases like this that would be, if you are interested, we can even discuss just after that. Yeah.
Highly complex. I didn't know tape was that complex.
That's it. Yeah, is a well unknown.
Yeah.
It's like
I really like the approach of the whole company. That so you give the real impression that you're trying to help out other firms and you're trying to find solution and are very solution oriented. And if you benefit your customers, you're also profitable and successful with it. So
that's the idea.
Thanks a lot.
Yeah,
thank you.
Thank you for your questions.
So, okay, there is another question.
All right, thank you. I was just curious on your internal innovation process and in what way you apply AI in it, because from the medical or healthcare sector, there are a lot of applications to use AI to find new protein combinations, and I was wondering how you can use it in chemicals to create new polymers, especially if you could ask a large language model, hey, I have a trigger with 65 degrees, what kind of constellations in my polymer do I need to have a new adhesive? So, yeah, and maybe also how you can speed up innovation processes to find new constellations in your adhesives.
Yeah, definitely. So then we have a very strong artificial intelligence strategy, so that we are applying not only in the development of the adhesive, but also in general for the whole company. This is a very, very strong and very well adapted through everybody in the company. And there is one part, obviously, in the technology development that we use AI to optimize our formulas, to find new formulas using algorithms. Yeah. So then we are using this kind of tools. Yeah. And this saves us time. We are faster to market. And we can optimize very well the process. Yeah.
But let me make one remark. First of all, you need to know something about my personal background. I used to work in theoretical chemistry, and I founded an organization in Henkel, but that was in the central R&D, God knows, 25 years ago. It was called scientific computing. You know what we did at that time? AI. Neural networks, machine learning, you name it. There were no large language models. Those are new, but the rest is old, 20, 30, 40, 50 years ago. So we already 20 years ago in other companies, and of course we've been doing that also at tesa, we've been using neural networks, quantitative structural relationships to build better formulations to improve things. Yeah, and I was very happy to see that now the computational power and the new models are so strong that we can finally predict, by the way, the 3D structure of proteins, which was a big problem for chemists for a long time. But now I will say one thing, but for me AI makes innovation more efficient. We are faster at finding the best spots in this knowledge space that we've created and that we fed into the model. For me, I've yet to see something that's truly intelligent, meaning that as disruptive, really something completely new from data that are old, so to speak, comes. I don't think this will happen. Maybe I'm a bit old-fashioned like that. For me, AI is a tool, and I sometimes don't even like this I thing in AI. It's an efficiency driver. It drives the efficiency innovation process. It drives the efficiency to have data analytics and makes faster, better formulations, but nothing disruptively new. I'm yet to see that. But please give me a different example if you have one.
We'll see in 5 months.
In 5 months. So fast.
It's going so fast, this thing, isn't it?
Yeah.
So, maybe in the next future, but I concur with you.
I just always think if you put data into something, it has a certain knowledge, but then to extrapolate it. In science, by the way, do you know where most of the innovation comes from? Where does the innovation come from? What happens?
I would say probably the mistakes.
Thank you. The mistakes, you blow up something, it's called serendipity. You stumble across something, you do something, and all of a sudden, whatever, there's so many examples in science. Hoffman, the guy that discovered LSD, what happened? He had this little thing on his finger, he put it on his lips, he drove home and couldn't remember how he got home. So then he discovered that this powder was LSD. But that's just one example. Thousands of examples in science where actually at the end of the day, most of the science is serendipitous. oh wow, you discover something curious, and you go into that direction. Do you think AI will be serendipitous? I'm not so sure. That's why I still think it needs smart young people like yourselves to actually go and be curious and try something new and fail and learn from mistakes, blow up something. I always say to my chemists, yeah, it's fine to have an explosion. Don't blow up the whole lab, please. Yeah, but if it makes a little poof, so what? Yeah, so important.
Okay, so there is one more question here, and I think you also want to ask a question.
Yeah, I already have a mic, so maybe I'll go first.
So let's start here.
Okay.
Never mind.
Sorry.
Thank you.
Okay, so you were faster. Yes.
Yeah, earlier today when you gave your keynote in Audimax, it has been mentioned that you were already conducting experiments in your childhood and that your neighbors were curious or did not know what you were doing. And I'm interested, what were the experiments? And I think that's also where all your curiosity and drive for innovation maybe comes from. But how do you also see that being fulfilled in your role as CEO?
Oh, that's a very good question. Well, first of all, I think, as a child, I had my little lab in my cellar, and my mother was always happy that the house that we lived in was still standing when she came home. She told me later. And but at that time it was a bit easier to get access to chemicals. Now this is very controlled. Yeah. So, but what I had a pharmacist. He always asked me, "What are you going to do with this stuff?" Yeah, and I always had two answers. But the one that was the boring answer, and I would do some little experiment and try and explain it to him. But then I would do something a little at home. I had some other applications, and to be very honest, I liked to blow up things as a 12 or 14-year-old. So I learned to control this, not only blowing up, but you know what I mean, a little bit, doing something a bit crazy. My curiosity, I think as a CEO, you also have to bring that to the table, and I think you have to encourage your teams to be curious and drive innovation. And I'm a super advocate. I hope to be a strong advocate for innovation, to drive science, and to encourage my people to be curious. I myself am curious, and we invest a lot. I'm pushing strongly to invest further in innovation and really investing more in R&D. I believe in technology. You can't save yourself out of a problem. You have to invest. And so, but David, maybe you can judge that. But I think encouraging innovation and encouraging failure, and if something goes wrong and it doesn't work, so what? Let's try again. Let's pick ourselves up and try again anew. Failure culture is important. Yeah. Yeah.
No, and it's, the topic, and it was mentioned before also about how our innovation goes and how we move on and so on. And honestly, I've been working in the US. I've been working here in Europe. I've been working in Spain and so on. And then every culture does it a little bit different. But one of the things is that move on, and then move on fast. Yeah. So then just be agile and then get things, and then if at the end you don't see it, and you modify. You don't have to wait until you have everything absolutely perfect, and then start doing something after. So just step by step, and then but fast. Yeah.
That's another topic. Huh?
Yeah.
That's why we keep telling our people also go for an 80-20 rule. You know the 80-20 rule, of course, yeah? Invest 20% of your time to get 80% achieved, and then try something new on top, rather than trying to make it. And we Germans are not so good at this. Yeah, we're super strong engineers. We want to always get it 100% straight at the first time. I don't think that's a good thing to apply. That's why a lot of cultures now are actually even speeding up, and we are struggling a little bit. Yeah, so fail fast, 80-20 rule, and then the other thing is own your projects. Meaning, if you want to do something, fight for it, go for it, then really own it with passion. Yeah, that's like we have passion for our topics. Be passionate about it.
Good.
Yes, my question was regarding your comment about the Chinese car industry. I was wondering if, because I mean, it's an expansion of a market that the Chinese car economy is growing, but it could also, due to the increased competition now, maybe drive down the prices that you might be able to ask for your products because of the increased competition and the German manufacturers' ambitions to now reduce their prices. So I just wanted to ask, are you benefiting from China's growth now as a car nation, or is it more of a threat to your profits?
That's a very good question. I would say a little bit of both. Yeah, in the sense that, as I said, I was in China just last week, meeting with a lot of the suppliers and so on, and they are super interested now about they're moving from, I think, technology-wise, from building commodity products to now building differentiated products, also in the automotive industry. And they're really good now. I mean, I sat in cars, I can tell you, incredible. Yeah, really, really modern stuff. And some of the European car manufacturers, they better get warm clothes, you know. So, and of course, yes, for them it's maybe also regional expansion. But I think you always start low in the commodity area and then you advance in the technology area. And that's where we can, of course, bring solutions to these customers, and they know that. And by the way, they also don't like American suppliers at the moment. I'm not, yeah, what a surprise, right? So there we, as a relatively neutral country still, in the sense, yeah, a supplier from Germany is still respected as something a bit more acceptable, I guess. And but the other thing, commodities, yes, of course, there's a price pressure, but we don't, how do I say, we make specific solutions for our customers, and we also don't sell our products cheap. Yeah, if you want to work with us, we will develop products for you. Yeah, but that means also we make sure that we have enough margin to reinvest in our technologies. And if they become commoditized so fast that somebody else will copy them, well, then we just have to invent something new. That's our, yeah. So innovation avoids commoditization. And that's how we answer that. And if then at some point you have a big product group which is completely commoditized, actually partially we step out of it. If you want cheap suppliers and you find somebody else, go for it. We sell solutions. That's why we maybe are not, the adhesive suppliers, just pure adhesives that have 15, 20 billion euro sales. We're focused on the high technology for the most part. Yeah?
Thank you very much.
Thank you very much also on both sides. I look at the clock. It's we are over the time, but I think we had a really good discussion, and thank you very much for the good presentations, interesting presentations. You see, there were a lot of questions.
Thank you for the questions and for the moderation.
Thank you for the question. I think we stop now the official part, but you can feel free to ask go on asking because now they are here, and now it's the time to ask again. Okay, though, thank you very much for coming, for being here, and have a good afternoon.
Thanks a lot.
Thank you very much.
Thank you.